Right folks, the second question on this page is very much similar, and it's very much the same thing as the last question that I went through here, and how we're going to use Cohen's principle to find true lengths of a generator. Now, it says, question 1b, it says, the given line AB is a generator on the surface of an inverted cone. So in this case, where the cone over here was an upright cone and it was standing with its apex up here and the circular part was the base, in this case our apex is actually A and the circular part is going to be up here. So it's basically taking this cone and putting it on its head. And it says A is the apex, draw the cone and identify the true length of the line AB. So once again, in plan this is quite simple. A is the apex and B is a point at the base of it, or in this case at the top of it, but it is still the base of the cone. And what we have to do is we have to draw the view of the cone in elevation and plan. So when we're drawing the cone in elevation and plan, taking A as the apex, which is going to be our center, to B, which is going to be our radius. So that is what I would see when I look down on top of it in plan. And in elevation, what I would see is the outside edge of the cone will come up here, and then the other part out here. Now in this case it's upside down, so we know that from B, that is actually going to be my overall height of it. So I could extend that all the way up to here and here. And at these 2 points then join them to A. Now like the last question, just going to do a quick explanation on true lengths and generators, because that is actually the question done there, but just going to run through the explanation of it now. So just bringing over this little graphic. In this case, once again, vertical plane over here where the elevation is, the horizontal plane here where the plan is, and when we look at it from this point of view, where the image of the cone is going to project onto the vertical plane, which is going to generate our elevation view. In this case, that is going to give us a triangle, and as we know, it's inverted, so it's an upside down triangle. When we look down top of it in plan, it's going to be onto the horizontal plane, and projected underneath it, what we're actually going to see is a circle. Now, if I was just to finish off that nice neat graphic, these points will come straight down, this will come down, and it will project out here, and what we would end up getting is, looking down on top of it, maybe something like that there. That's the image of what we'd see. We would see a circle in plan, triangle in elevation. Now, what we have to be able to start that was, in plan view, we were given A, which was the apex of it, and we were given point B, which is obviously going a point where the cone ended on a part of it at the base of it. So, using that principle of finding the extreme generator, what we would do is, like the last question, it's the exact same thing. We are literally just going to rotate it around until it is at the side. So from A, it would rotate around here until it comes to that point there. And at that point there, it's still a generator. That would join back to A. And the image of that line is actually, if we were to follow that up along here, this point right here. And remember, this point was called point B. B has just rotated around. So here's our B. Here's our A. That means that this line here is our true length. And the reason for that is because A here up to B would be seen like that in plan. Whereas the original one was like this. And all we did was we rotated it around. So if I was to find the image of this guy, he was originally something like this. And as we rotate it around, that rotated is just a straight line, because that's all we see it as in the elevation. And what we have there now is the extreme generator, but it's also our true length. Okay, so in this view here, to be able to get the true length from A, do line across, and just remember, from B, all we did was we rotated until B hit here. That is the new position of my B, which is up here. That rotation, as I said, is seen as a straight line here, and that means there, B to A, that line there is my true length. And once again, why is it a true length? Because in plan we have the line AB, which we have now rotated around, is parallel with the XY line. That means it is a true length in elevation. So there I have true length line AB. Okay, I hope that helps. That is the two questions there complete.